Welcome to this third video on instrumental variable. In the first two videos, we have discussed instrumental variable regression and general instrumental variable regression along with identification, definition and two-stage least square. So in this video, I am going to discuss relevance of an instrument, checking instrumental validity. Second thing is checking instrumental exogeneity. What happens if you have a weak instrument? What happens if you have endogenous instrumental variables? How we test whether instruments are endogenous or exogenous? And in the next videos, I will have a workshop and from where do these valid instruments come from. So let's come to the main topic of this video: instrumental relevancy and instrumental exogeneity in practice. So you see, we have two basic requirements. An instrument is relevant if it is correlated with X. Endogenous regressor is X. And secondly, all instruments should be uncorrelated with U. So what happens if these assumptions are violated and how we deal with this? So first assumption is that you must have these pi's, pi coefficients, at least one of them should not be equal to 0 for an instrument to be valid, and X is your endogenous regressor. So if it is these are all equal to 0, it means instrument is weak. What are the implications of a weak instrument? That's what we are going to discuss. You see, we have covariance between SXZ. If it is very small, it means beta 1 2 SLS may be very volatile. It may fluctuate a lot. So if it's close to 0, then beta 1 2 SLS may go to infinity. So basically, weaker this relationship between X and Z, poor the distribution of 2 SLS, and it will be no more approximately normal, as is often the case in two-stage least square. So if you have invalid instruments, you have weak instruments, your distribution will follow like this way. I'll demonstrate through simulation at some time. And if you have valid instruments, your instrument the distribution look like this dotted line. So what happens if you have weak instruments? Your standard statistical inference will not hold. So basically, this will become a ratio of two normals, variables, and your standard statistical inference will not hold. You will have less than 95% confidence in plus minus 1.96 standard errors. And it's a case just like small sample size. As in small sample size, if exact distribution of beta is not or U is not known, you'll have an issue. But for that, watch my video on sampling distribution of OLS estimators. So how to test whether an instrument is weak or not? The mechanism for this one is that regress X on all instruments and all exogenous regressors. Exogenous regressors I have discussed in my video 2 on instrumental variable regression. If this F statistics is less than 10, instruments are weak. If this F statistics is more than 10, instruments are strong. That's that simple rule of thumb. That if you have regress your endogenous regressor on all the instruments and exogenous regressors, if coefficient of all instruments is 0, then your instrument is weak. If F statistics obtained is greater than 10, then instruments are strong. I'll demonstrate in this video using cigarette demand data. So if you have weak instrument, what to do? Okay, get better instruments. Easier said than done. Not a joke. It's a tough task. If you have many instruments, then you can drop weaker, you can pick the stronger. Okay, If you have few instruments and all are weak, that's the name of the game, then you need to use a method other than two-stage least square, which we'll discuss at some other stage. At the moment, I'm not going to discuss those methods. So, second, instrument exogeneity, that your Z should be uncorrelated with U. So this is your second second assumption. In the first assumption, we have seen that if your weak instrument, it means it explains less variation in X. If you have strong instrument, it explains more variation in X. Here the second condition is that whether the Z, which explains less or more variation in X at first stage, relevancy stage, whether it's exogenous or not. No, you have again two conditions. One is if you have number of instruments equal to number of endogenous regressors, that is X, number of X is equal to number of Z's, then you cannot test exogeneity. That is, if the case is exactly identified model, then you cannot test exogeneity. If you have over-identified model, you can test whether an instrument is exogenous or not. How do we do? Let's see. So, very simple. First of all, regress, we get E hat or U hat by using 2SLS, as I explained in my previous video, and in this video as well I will explain. And then the E hat obtained by using this 2SLS, regress this E hat on all Z's and all exogenous regressors. If this F statistics is significant, it means you have endogenous regressors. H naught is all instruments are exogenous. If this null hypothesis is rejected when you regress this E hat on instruments and exogenous regressors, it means instruments are not exogenous. If it is not rejected, it means instruments are exogenous. So our test statistics is J is equal to MF with M minus K degree of freedom. I'll explain how we carry out this process. If M is equal to K, then you cannot do this test of exogeneity. If I summarize these two things, first one is relevancy. At least one instrument must enter the population, counterpart of the first stage regression. If instruments are weak, two-stage least square is biased towards OLS, and T statistics has a non-normal distribution. Whether an instrument is weak or strong, you need to carry out an F test. If its value is less than 10, you have weak instruments and go for method other than 2SLS. If you have a second one, and secondly, weak instrument basically reflects that it explains less variation in X. So R square will be low. A second thing is instrumental is exogeneity. So we carry out J test, and null hypothesis is instruments are exogenous, alternative instruments are endogenous. So in this case, if a system is over identified, you can carry out this test, otherwise it cannot be carried out. Let's apply these concepts to secret demand data. So I will do all this in my next video of workshop on this. Step by step I will explain all these steps in using Stata and R. At the moment I'm just going to explain the results. So estimation strategy. Okay, one more thing. Here again we are using the strategy of panel data. We have basically 10 years time period data, so we are going to, there can be many other variables which are unobserved and not included in the model, or maybe we don't have data on them. So what to do? They are also they may also be correlated with they may also be influencing cigarette demand. For example, cigarette producing states, regions, they have taxes culture different than others. So when we take two time period difference, those omitted variables on which we don't have data or which remains constant over time, their effect will be eliminated. So I will explain this in the workshop. So you have 1995, 1985 quantity demand, price, income. So you have constructed these variables and then you estimate this cigarette demand elasticity. Okay, 10 years change in log of price. We'll generate all these variables using workshop. I'll explain in detail. Okay, again, instrumental variable, first stage, you have here only sales tax as an instrument. Here you have income per capita and sales tax as an instrument. You obtained, okay, first stage F statistics is greater than 10, which means instrument is strong. You have regressed X on sales tax and cigarette specific tax and income per capita. Your F statistics is greater than 10, so both instruments are not weak. So in all these three cases, I'll explain with the help of a table, final table. In all these cases, each instrument is very strong instrument. Now we regress to test whether instruments are exogenous or not. So for that, first of all, regress instrumental variable cigarette consumption on per capita income and both instruments. You will get E hat from here. Regress that E hat on both instruments and exogenous regressor, and then test whether these two coefficients are jointly equal to 0. If they are jointly equal to 0, then instruments are exogenous. If they are not, then they are not exogenous. So here you have 0.026, 0.096. Basically, this is slightly different, but here we reject the hypothesis of exogeneity. I'll explain. This is the case. Okay, p-value is not valid. Yes, this is the valid p-value. So we reject the null hypothesis that instruments are exogenous. So it means either sales tax is not exogenous or cigarette specific tax is not exogenous, or both are not exogenous. Okay, I'll summarize these three things here. First of all, we have used 10 years time period change, and we are testing two things. First is instrumental relevancy, whether instrument is weak or strong, and second is whether instruments are endogenous or exogenous. So first stage F statistics is 33 when cigarette specific tax is used, sales tax is used. When cigarette specific tax is used, again it's significant. So both, and when both are used, again F statistics is greater than 10. So in all these three cases, you have very strong instruments. First issue is resolved. Weak instrument issue is resolved. You have all three cases strong instruments. Second issue, that whether sales tax or cigarette tax, they are exogenous or not. So our null hypothesis is that both are exogenous. If they are exogenous, then the difference between these two will be very close to each other. That will be only due to sampling variability. But if they are endogenous and their differences are very large, so it means either of these two or both are endogenous. So what do we see here? That instrument exogeneity is rejected. So it means either this or this or both are endogenous regressors. What to do? No, you don't have any statistical mechanism to decide which one is endogenous, which one is exogenous. Here comes your economic theory, here comes your subject matter theory. Decide on the basis of that. Sales tax may be a better choice because cigarette specific taxes are often driven by political needs, cigarettes producing regions and other factors. Basically, they influence cigarette specific taxes. Since both are strong instruments, no, it depends whether you are using sales tax or cigarette specific tax. It may vary from one country to another. So you can decide accordingly. Whether this elasticity is small or large, okay, for 1% increase in prices between these 10 period in 1 year leads to 0.94% decrease in cigarette demand, which seems slightly on lower side, but you see we are changing, we are studying the behavior over 10 years time period. So when you take it over 10 years time period, it's a very reasonable reduction. So we assume that cigarette specific as increase in cigarette prices leads to lower in demand in cigarette over time. Thank you for watching. I will do all these things. I will construct all these tables, and you have many other variable constructions in Stata and are in my workshop on instrumental variable. Thank you for watching, and in the final video I will show you more examples of instrumental variable.